So this is 3.7, A is an alpha, page number 277. This is on variation. Now this section is going to deal with two different kinds of variation. So let's just bring up the first one first, and then we'll talk about the other one later rather than give you both of them right now. So the first one is called direct variation. The book doesn't really give a lot of explanation about what direct variation is, but they do give you an equation that looks like this. And direct variation is basically multiplication. So we have k, where k is a non-zero constant or a non-zero number, and it's called the constant of variation. And for the most part, when we're doing these problems, the book will say y varies directly with the variable x. So y varies directly with the variable x. That means that we're going to multiply x times k, and that will give us y. One of the things you'll notice here is there are three variables here, or three unknowns here. So when you're doing direct variation, and later when you're working on the second variation, which is actually called inverse variation, you're going to have a k. And you're going to have to find the k first before you are able to find out the rest of it. So if you look at the top of page 278, which is right there, you can see that there are some phrases that they give you. Y varies directly with x, and that's what I just showed earlier. Y equals k times x, and this k is a number. S varies directly with the square of t, so S varies directly with the square of t, t squared. Y is directly proportional, so you've got the word directly in there, so it doesn't matter if it says varies directly or is directly proportional. It means the same thing, that word directly, to the cube of z. So y equals always k times whatever the second part is. In this part, it's the cube of z, or z to the cubed, third power. U is directly proportional to the square root of v. So just see how these equations work. You've got your first letter, varies directly, which means k is multiplied by the second part of this, the other variable, the square of t, the cube of z, the square root of v, etc. Okay, so let's look at one of these and see what we need to do in order to figure these out. So example 1 gives us y varies directly with x. So I know this is my equation. Y varies directly with x. If y is 15 and x is 5, they want us to find y, that's a question mark, when x is 7. So this is our second part of the equation. That's a 7, sorry. This is our first part. So remember a little bit ago I said the first thing we do here is we find out what k equals. That's what we use our first part to find out. Then we use our second part to find out what, in this case, what y is. So let's go ahead and do that. So I'm given this bit of information. Y is 15. We are looking for k, x is 5. Divide both sides by 5, and we get k equals 3. So let's look at this problem again. Y equals kx, but now we know what k is. Okay? But they also told us what x is. They said, what is y when x is 7? So we're going to erase the x and put in a 7. So when x is 7, y is 21. So again, the keys in order to do this. First of all, use the information that they give you to find k. So they've got to give you an x and a y. somewhere in there to find k. And then they're going to give you another x or a y and tell you to find the other letter. Well, now that we know what k is from the first step, we can plug the number they gave us in, and then we've only got one variable that we're looking for. So let's look at example 2. So go, a skyjumper jumps from a plane like any object that falls to earth. The distance the skydiver falls is directly proportional. So it's an equation that looks like this. To the square of the time he has been falling. So the distance the skydiver falls is directly proportional to the square of the time he has been falling. So we're looking at the distance. So instead of a y, we're going to use distance. And it's directly proportional to the time. So we're going to label it like that. Because remember when we did the functions in the last section, this was another way of writing y. So, and we're using d in time because we're looking at distance. All right, so it's directly proportional to the square of the time. Okay, until he reaches his terminal velocity. Terminal velocity is when you are free falling, it's the maximum speed. You're not going to keep speeding up until you're going an infinite miles per hour. There will be a certain speed, certain velocity that your body can only fall as fast as. That's called the terminal velocity. If the skydiver falls 50 or 64 feet in the first 2 seconds of the jump, how far will he have fallen? This is A, after 3.5 seconds. Okay, so first of all, we have to find K. So what information do we have? We know that T is going to be, what does it say? 2 seconds, 2 squared. And we know our distance is, he falls 64 feet. So this is going to change. 64 equals K times 4. Divide by 4, divide by 4. And we end up with K equals 16. So that's what we're looking at first. Now we can look at A, B, and C. So we're going to use d of t equals, we know K is 16, t squared. So this is a formula we're going to use to answer A, B, and C. So A says, how far will he have fallen in 3.5 seconds? How far? Distance. So that's what we're looking for. Distance equals 16, how much time? 3.5 seconds. Okay. So 16 times 3, well, actually, let's write this all the way correct. We'll put that as 3.5 because it's the distance in 3.5 seconds, because we're replacing t for time with 3.5. So we have the distance in 3.5 seconds is going to be equal to 3.5 squared times 16, which will be 196 feet. The B part says graph the relationship between distance and time. And that is not too hard because all we need to do here is make a graph. And the x-axis will be time. That's usually the case, is the x-axis is the time. And the y-axis is the distance. And when he jumps out of the plane, no time has started. He hasn't gone anywhere. And as we put in numbers for time, so if we do x, y, and we put in, let's say, 1 second for t, 1 times 1 is 1 times 16 is 16. Put in 2 seconds. 2 times 2 is 4 times 16 is 64. Okay, and you just keep putting in numbers and you'll end up with a graph that goes like that. Because we graph 116 to 64, and we just keep going until we have enough points on there to make that graph. Then C says, how long will it take him to fall 256 feet? So you can look at the table or the graph here and be able to tell when this number becomes 256, you can look down and see how much time he's gone. And in this case, if you look at the graph on page 279, let's see, 256, looks like it's right around 4 seconds. But if you want to use this formula here, you can do that too. Because what are we asking for? 256 feet. So the distance, 256, equals 16 t squared, because we're looking for time. So how long will it take? Divide both sides by 16. And 256 divided by 16 is 16. Okay, so this is saying what number times itself will give me 16? And that answer is 4. So if I square 4, I get 16. So I know t has to be 4, so it takes 4 seconds. So you can do it mathematically as well. So that's all there is to direct variation. Now there's another one that I had just briefly mentioned. I said we're going to get into. It's called inverse variation. And instead of y equals kx, it is written as y equals k over x. It is done the exact same way. Find k first, and then you're given an x and a y, and then solve it from there. I would suggest on page 280 that you skip the discussion on photography, because that just, to me, just confuses me, because I don't really know much about photography. So that doesn't really help me to understand it. But if you know direct variation is there, or directly proportional, this is inverse variation or inversely proportional. The only difference is one is multiply, one is divide. That is the only difference. So let's look at example 3. The volume of a gas is inversely proportional. Volume of a gas. So for y, because volume is first, it says the volume of gas is inversely proportional to the pressure. So because it said inversely proportional, I know that my first value that they bring up is V for volume. My X value is going to be down here, and we're going to call that pressure. If the pressure of 48 pounds, so remember we're finding K first, so they've got to give me the pressure and the volume so I can do that, to a volume of 50. Okay, so there they've given me enough information that I can go ahead and find what K equals. So now, because that's in the bottom, I'm going to multiply both sides by 48. And those will cancel. And I get K equals 2,400 when I multiply 48 times 50. So now I have my K. So now I can go back to my original equation right here, and I can write it as P, oops, I'm sorry, not P, V equals K, 2,400 over P. So I guess I took this formula here. Now I have a K, I can write it that way. So they're asking what pressure is needed to produce a volume of 100 cubic feet. So what are they asking for? They're asking us to find the pressure. What pressure, given that V is 100. Okay, so multiply both sides by P. P's cancel. Divide both sides by 100. So I have P, because those go away, equals 2,400 divided by 100. And I get 24. So if my volume is 100, then my P, my pressure, is going to be 24. And that's all that is. Okay, so hopefully that's enough to get you moving, because that's all they give us for examples for inverse variation. So what we're going to do now is part C, is called joint and other variation combinations, and we'll do that on the second video.